Phase changes occur when a material changes phase. So you could have a material going between a solid and a liquid and a gas, or even a solid and a gas. So below in these two pictures, you can see some examples of some phase changes. There's a pot with some boiling water. So the water is transitioning between the liquid phase and the gas phase. Then we also have a picture of some dry ice sublimating. So dry ice will go directly from being solid carbon dioxide to gaseous carbon dioxide. Phase changes always require energy or release energy. So if you have a pot of water boiling, you have to add energy in order to get the water to go from a liquid to a gas. If, on the other hand, you take some gaseous steam and then you condense it, then that requires the removal of energy. When a substance goes through a phase change, the temperature remains constant. So when you are boiling water, the water remains at 100 degrees Celsius until all of the water is boiled. So the total energy that's required to complete a phase change, we can write that down as being Q, the heat that's either put into the material or extracted from the material, is equal to plus or minus the mass of that material times L. And L is the latent heat of a substance. Now that plus or minus sign specifies the direction of the phase change. Are you boiling the water, or are you condensing the water vapor into a liquid? So if you are doing something where energy is absorbed, like boiling the water, then that you would want to use Q is equal to positive ml. If you have to remove energy from the material, then you would use the negative sign. L, this latent heat of a substance, depends not only on the type of material, but also what kind of phase change you're doing. If you're going between a solid and a liquid, so if you're either melting something or freezing it, you would use the latent heat of fusion. If, on the other hand, you're going between a gas and a liquid, so you're boiling or condensing, then you would use the latent heat of vaporization. On the other hand, if you are going directly between a solid and a gas, like you can do with carbon dioxide, then you would use the latent heat of sublimation. So you can find tables with all of these latent heats for various materials. Some of these tables are in your textbook. So let's look at a particular example where we have to consider some phase changes. If you are heating water from minus 20 degrees Celsius to 200 degrees Celsius, how much energy would that take? Well, you would need to add together not only the heat necessary to cause this temperature change, but also the heat necessary to accomplish the phase changes that you would encounter along the way. So initially, if you have water at minus 20 degrees Celsius, what you actually have is a block of ice. And so first off, you would have to add an amount of heat equal to the mass of the ice times the specific heat of ice, which is different than that of water, times the change in temperature, and the change in temperature would be from minus 20 to 0. Once you hit 0 degrees, then the water starts to melt. So until the water has completely melted, it remains at 0 degrees Celsius. And then the amount of heat you would have to add would be equal to the mass of the ice, which turns into the same mass of water, times the latent heat of fusion. Then once all of the ice has melted and become water, then the temperature of the water starts to increase. And you would need to add an amount of heat equal to m, where m is the mass of the water, times the specific heat of water, times the change in temperature from 0 to 100. Once you reach 100 degrees Celsius, the water starts to boil. It starts to turn into water vapor, which is gaseous water. And so while you are boiling the water and the water vapor remain at 100 degrees Celsius, and you have to add an amount of heat equal to the mass of the water times the latent heat of vaporization. Finally, you end up with the same mass of water vapor. And to raise that water vapor to 200 degrees Celsius, you have to add an amount of heat equal to mc delta T, where this is the mass of the water vapor, which is the same as the mass of the ice you started out with, times C, the specific heat of the water vapor, times delta T, where this is the temperature change between 100 and 200 degrees Celsius. So you can see that the amount of heat we have to add has to accomplish the phase changes that we encounter along the way, as well as causing that overall increase in temperature. So let's look at this question. In cloud formation, water vapor turns into water droplets, which get bigger and bigger until it rains. Will this cause the temperature of the air in the clouds to get warmer, get cooler? Will it not have an effect on the temperature of the air, or is there no air in clouds?